Hello, welcome back to JD Science Prep. Today we are discussing predicting products of single replacement reactions. So if this video does help, please like and subscribe. So what I have going on, we are going to discuss different scenarios for single replacement reactions, and then we have 5 examples to go through in the second half of this video. So it says in single replacement reactions, a lone element will replace another element within a compound. So within a compound. And if the lone element is a nonmetal, it's going to replace the anion within the compound. So taking a quick look at, we have sodium bromide reacting with chlorine gas. Our lone element here is chlorine, and since it's a nonmetal, we'll want to replace the anion in this compound here, which is going to be bromine. So we can go ahead and write out the products for this. So we have sodium chloride now, so NaCl. And since bromine was basically kicked out of the compound, it's now going to be the lone element on the product side. So we'll write down Br2 as that lone element, and now we just have to quickly go ahead and balance this. So we can write a 2 in front of NaBr, a 2 in front of NaCl, a 1 in front of Cl2, and a 1 in front of Br2. So that's scenario 1. Scenario 2, it says if the lone element is a metal, it's going to replace the cation within the compound. So here we have magnesium as our lone element. It is a metal, so it's going to want to replace iron 2 in the compound. Okay, so we can go ahead and write out our products here. So magnesium kicks iron 2 out, which results in MgNO3 and then since iron 2 was kicked out of its compound, it's now going to be that lone element on our product side. So let's write out iron as our lone product, and we can go ahead and balance this. So we are going to have let's try a 1 in front of iron 2 nitrate, 1 in front of iron, and then we'll put a 1 in front of MgNO3, and finally a 1 in front of magnesium, and that looks pretty good to me. So one key thing here, we haven't quite talked about everything yet. It says not all single replacement reactions will go through, and this depends on the activity series, which we will see right here. So we have this activity series, and basically what it has is a order in which what elements can replace what. So we said that metals will always replace cations, and non-metals will always replace anions. So basically on our left side here, we have potential cations being replaced, and on the right side, it mostly just applies to halogens. Okay, so we'll be dealing with fluorine, chlorine, bromine, and iodine. So let's take a look at number 1 here and see how we can use this activity series to correctly predict these products. So looking at number 1, we have sodium chloride is reacting with potassium. So how we're going to use this activity series, the lone element, in order to kick out, in this case, sodium, potassium has to be higher on the activity series in order to kick out sodium. Okay, so let's take a look here. I'm going to zoom in a little bit. We have potassium. It's actually the 3rd highest on the list. Okay, and then we have sodium a little bit lower. So since potassium is higher on the activity series, it has the ability to kick sodium out of this compound. Okay, so this reaction will go through, and let's write out our products. So we are going to have potassium chloride now. Remember, potassium is going to kick out the cation, which is sodium. And since sodium got kicked out, it's going to be the lone element on the product side. And this one should be pretty easy to balance. It's going to be 1s across the board. That is done. So let's take a look at number 2 here. We have zinc oxide reacting with nickel. So we have to look at where zinc and nickel are on the activity series. So I'm going to zoom in a little bit here again. We have nickel, it's pretty low on the list. It's the third lowest. And then we have zinc up here. So since nickel is trying to replace zinc, but it's lower on our activity series, this reaction will not go through, okay? So I'm going to write no reaction for zinc oxide and nickel since nickel is lower on the list than zinc. Let's move on to number 3. So we have magnesium bromide and fluorine reacting. I'm just going to drag this activity series down a little bit so we can keep using it. So this time we have we don't have metals trying to kick one another out. We have non-metals. So here, let's see if we can find fluorine on our halogen activity series. So we have fluorine right there, and we have bromine all the way down here. So it looks like fluorine does have the ability to kick bromine out of this reaction. So we will write our products here. We'll have MgF2 plus our lone element in this case is going to be bromine since it was kicked out of its compound. Okay, so let's go ahead and balance this. It's going to be ones across the board again, pretty easy. That looks good to me. Moving on to number 4, we have sodium and water reacting. So how does this work? Since we have a metal as our lone element, but we do not have any metals in our compound. So if we take a closer look at our activity series here, we see sodium is in this little section of our activity series. And if we read this little part right here, it says reacts with cold H2O and acids replacing hydrogen. So all of these metals here have the ability to replace hydrogen in water when it's reacting with H2O. So we know that sodium and water, sodium's going to have the ability to kick out a hydrogen atom out of the water compound, which will result in sodium hydroxide. And since since a hydrogen was kicked out, it's going to be that lone element. And just remember, when hydrogen is alone, it has to be written as H2. Okay, H2. So let's go ahead and balance this up real quick. So we'll put a 2 in front of NaOH, 2 in front of sodium, a 2 in front of H2O, and finally a 1 in front of H2. That looks balanced to me. And let's move on to our very last example here. So we have aluminum reacting with hydrochloric acid. I'll just drag this activity series down a little bit more, and we'll finish this video up. So we have aluminum and hydrochloric acid. Let's see if we can find aluminum on our activity series. It's right here. And again, we don't have any metals at all in hydrochloric acid. However, if we read this part right here, it says reacts with steam and acids replacing hydrogen. Okay, so hydrochloric acid is our acid here, and aluminum has the ability to take the place of that hydrogen atom in hydrochloric acid. So aluminum is going to then create a compound with chlorine. So we can write down that product. We will have AlCl3. And our other product, what got kicked out, what is now alone, is hydrogen. And since it's alone, it's still going to be H2. Okay, so we will try a 1 in front of aluminum chloride and a 3 in front of HCl. Ooh, that's not going to work. Let's erase. So we'll try a 2 in front of AlCl3. How about a 6 in front of HCl, a 3 in front of H2, and a 2 in front of aluminum? That looks balanced to me. If this video has helped, please like and subscribe. Thank you very much.